Okay, so remember, all the stuff you can go ahead and graph, but horizontal shifts, if it was like H was a positive, it would look like this right here, okay? And if you look at that -2, it was really a +2, so it went to the right 2. Here it was a -1, but it was minus a -1, so it went to the left 1. And that's it. Quickly, I'll review these. We did these yesterday. But if you look at these two, the original, the parent function goes from the origin straight up like this. Here, this is a 3, so it basically slides it over, 1, 2, 3, and it goes up here. Okay? That's this one right here. This one over here, I should change colors actually. This would be the parent function. The parent function, guys, y'all remember, is going to be x squared. This one here is a minus a -2, so we're going to go, whoa, guys. I did that one wrong. Now it goes to the right. My bad. That's a +3, so we go 1, 2, 3 to the right. And I'll do that one in blue now. 1, 2, 3, and we'll go up to the right. It's a +3. Here is going to be the parent function in this situation. It's still going to be x squared, which is that one. So please remember, that one right there is a double negative. Man, I don't know what I was thinking. Double negative. So that one right there in that situation, we're going to go to the left 2. 1, 2, and we go up. These two are the same width. Don't forget. Now, I'm going to show you in the calculator, guys. I guess I'll show you this one, -3. How you can look at this in the calculator. Make sure you know you turn on the calculator. Do go to a new document. Do not save it. It's asking if you want to save your old stuff. The parent function is going to be x squared. Okay, I'm looking in the chat, guys. I need you all to help me out. What do I press to get the new, to put a new graph on there? Help me out, guys. What do I press to go to where I can type in a new graph? Come on. Thank you so much. Tab, right? Then in the one they gave us is going to be x minus 3 squared. And then there it is. It just scoots over 3 units. 1, 2, 3. So remember, you can go ahead and, the calculator is fast, but if you see that and recognize it, you're faster. Okay? So the book is going to be cool. The book is awesome. It shows you a lot of tricks. I want you to do both. I want you to know how to do the, by hand, and I want you to go ahead and know how to do it by the calculator. Sky's the limit how you do it when you test. Now, this is the next section. This is kind of where we left off. So in this situation, it's a combination. This is going to move it, what, up 2, and this will move it to the right 3. You got that? You see that? The parent function here is f of x is equal to x squared. Now, this one here, it's a combination. This stuff moves it to the right. This one moves it up. So you go 1, 2, 3 to the right, and then 2 up. And graph it here, same way. This one, it's a combination of both. This moves it down 1 and 3 to the left. So 3 to the left from the origin. The parent function, the blue one. 1, 2, 3, down 1, put my coordinate there, and graph it. What do y'all think, guys? Not too bad, right? You will be doing this today. You have an assignment on Alex for this part. Okay, so let's go ahead and do this one real quick. Let's copy this down, guys. They want you to compare it to what? I guess they did parent function in blue. I'll do parent function in blue also. They want you to compare to parent function. Okay. So in the parent function, don't forget it's f of x is equal to x squared. So for this one, I'm going to have this coordinate like this, and then this one goes up from the origin. Okay. Same thing for this one right here. So let's look at this one, guys. What does this one do? Can y'all help me out? In red. What does this do? Right or left? Help me out. And how many? What does this move it? We got to remember from yesterday. This one moves it. How many and which direction? Okay, I know you gotta take time to write it out. Write it out. Ooh, I have a right and a left. I have two lefts and one right. Yes, left. So you see that one? I did mess up in the beginning. This is a minus a negative 2. So this part means go to left 2. So we're going to go 1, 2 to the left. Okay, that goes to the left. And what does this one do here now? Up 3. Good. So we're going to go 2 to the left and then 1, 2, 3-ish. Put my vertex here and then it opens up. Pretty cool? Not too bad, right? They're pretty easy, guys. They're not too bad. Let's try this one over here. Try this one all on your own. Copy that down. Again, they want you to compare it to the parent function, so I'll graph the parent function. The blue one is f of x is equal to x squared. The red one here is this red one right there. This one here, good. I know you need to take time to write it out. Is going to be x squared, or you can say f of x, the parent function, right, is equal to x squared. That's that graph. The red one now is going to be g of x. Okay, so I think y'all might have enough time. You might be drawing this already, be done with this part. I'm going to go ahead and just show you the way to do this one, because you should do it on your own already. You should have it done, and let's see what we get. Ready? This moves it to the right 4. 1, 2, 3, 4. Right here. And then this moves it down. 1, 2, 3, 4. Put my coordinate, my vertex there. And it opens up there. At this point right here, we're going to have this one known as g of x. Good job. How was that one, guys? Not too bad. That's where we kind of left off yesterday. We're picking up there, running with it. So I do want you to look at this, guys. Every single one, I've done it like this. Every single one. Are they all up? Don't some go narrow? Aren't some really wide? Some even go down. Okay, so you're going to be aware of that. They're not all like this. So you have to kind of look at that stuff. So let's go to the next part. So with a dilation, guys, when a dilation is basically you need to write that word down, dilation. Please do me a favor. And write the word multiply. Okay? When you multiply something, you're going to dilate it. Now, what do you mean? Well, if you want it twice as big, you multiply it times 2. Dilation, like your pupils, you want to open them up bigger. If you want to make it half the size, then you multiply it by half. Okay, so if you want to dilate something, you go to multiply. And that's it. You just kind of work with that idea. Is multiplied by some constant A. Okay, we got to go fast. Now look at this one real quick. So dilations. When it comes to dilations, the original parent function, again, is still going to be g of f of x. And that's going to be x squared. That's your parent function. If you look at this, there's a number here, and there's a number 1. But what does that do to it? Nothing. It just leaves it the way it is, okay? But if you put an a there, that isn't 1. And a absolute value is greater than 1. What does it do? It makes it take off real fast. Shoot up real fast. Think about that. The values. Put in the x value, my y value is way bigger because I multiplied by something. Now, if that's like a 2, a 3, a 4, a positive or negative, these numbers, right? It makes it take off faster. Now, what if your number is between a 0 and a 1? Basically like half, like a third, like 5/7. You see how this stuff right here doesn't make it take off fast? It says 8. X squared, and then multiply it by half. So it keeps the numbers low. Doesn't make it go wide, or make it take off real fast. So do me a favor, copy this part right here. Make sure you know we're talking about this part. I'm going to just kind of quickly give you an example real fast. This would be like f of x is equal to 3x squared. An example, this one over here would be f of x is equal to 1/2 x squared. Keeps the values down, keeps it wider, okay? Now this LAL, it's not LAL, it's the absolute value of A. Okay, so the absolute value of A is greater than 1, it makes it go fast, big, take off really quick. Okay, guys, copy it down, let's go, let's go. I'm going to move it up. Okay, I'll give you about maybe, whoa, what did I do? Where did we go? Give you about maybe 10 more seconds, okay? Another move on. Okay, let's go and look at this real quick. Now look at this, it's like half, okay? Half. There's no plus, there's no minus over here, so it stays at the origin. And since this one is going to be wider, the parent function, guys, the parent function, and I pointed this out earlier. I said the parent function goes from here, and it goes 1, 1, 1, 1, and it goes through those coordinates. There's a reason I've been saying 1, 1, 1, 1. So when this one's wider, or I'm sorry, when these numbers right here, this number here is like wider. Pay attention when I'm saying wider, because it's going to make half x squared, make me half of it, don't go up that much. 2 squared, half of it, don't go up that much. Got it? So in this situation, this one, the red one right here, now stays wider. Okay, we don't want green, they don't want green, so I'll go with green. It stays wider. So the way you would graph it, just kind of, you can do this with graph trace, you can do this with your calculator really precise, but for me, you're good like this. You do know that the parent function goes like this, and name that one as parent function, or you can put it as x squared. When you put this other one, you better make sure it's wider. Understand that? Make sure it's wider. And then you can put h of x here. Look at this one real quick. This one does, well, the 3 makes it more narrow, and then this one right here moves it up 2. So it's a combination of stuff. Parent function again. The parent function here, I'm going to go 1, 1, 1, 1, goes through there. This green one, g of x, now is going to go up 2 units, go up 1, 2, and then it's narrower. So if I were to get this green, I'm going to trace it. And I were to bring it down to where the other one is at, right there, you can see that it's more narrow. And it has to be more narrow than this one because this is a greater number. Absolute value is greater than that one, slash makes it take off faster. Okay, how do we feel on that one, guys? I did those two. Now let's do, we do both of these, and then you're going to do this one on your own. Okay? Remember, in all this stuff, you can use your calculator. Okay, and all this stuff that we're doing right now, they want you to compare it to the parent function. So like what I always do is I always graph the parent function first. And this one here is x squared, okay? And that one's going to be your parent function. So you can know that one. This one here, help me out, guys. Is it more narrow or is it wider? What? More narrow would be like this. Takes off. Wider would be, that's narrow. Wide would be like this. What do y'all think, guys? Is it more narrow? Is it more wide? Ooh, wow. Awesome, guys. Come on. This number makes it more narrow. Okay, since that one's bigger than 1, one is going to be greater than 1. It means that when I go x squared times 2, my y values are bigger now. So it's going to go be more narrow. Now, I do need to talk to you guys, seriously. Jeez, I need to mention this real quick. If you're going to take a star, I don't know what to tell you, but on star test questions and benchmarks, these words come out. You see this one right here? Narrow. This one is stretched. I should add this already. Stretched vertically. So I like to think of a marshmallow. If you think about a marshmallow, it's kind of like this shape-ish. It's not like perfectly round. But if I were to stretch it out here, wouldn't it do that? Wouldn't it become longer? All right, so we stretch it vertically. This one here is what? These are words from your star test. Stretched horizontally. What? Does that make sense, guys, what I'm putting there? Well, on this one right here, if I stretch it to the sides, it gets wider. And it's like a marshmallow. Yeah, it would get wider. I'm going to mess with your brain if you don't mind. I'm going to mess with your brain a little bit. On that same note, marshmallow style, you see this? How could I make this thing? Instead of pulling or stretching it out, I can do what? Compress. Does that make sense? To make it look like this, to make this marshmallow look more like slender or thinner, and I'm not stretching it, I'm squashing it, compressing it, I would compress it what? Anybody know? These are words from the STAR test. I don't know. You have to be able to understand what these mean. Compressed horizontally. Jasmine, you're number one reader in the school. Double L. No pressure, Jasmine. Seriously, Jasmine? What's going on? Are you even here? Breaking my heart, Jasmine. Okay. So let's look at this one. If I were to compress it this way, push it this way, wouldn't it get bigger like that? Pretty crazy, right? Now let's look at this one. If I want to go ahead and get this marshmallow to do what? To go wider, but I'm not going to go ahead and stretch it. I'm going to compress it. Compress it which way? Compressed vertically. Does that make sense? So if I get a marshmallow here and I squash it here, it kind of like squashes out to the sides, right? Kind of squashes out to the sides and gets a little wider. So that's what we need to be aware of. You need to be aware of these words. I don't know who's taking the STAR test, benchmarks, or whatever, but just in case, those do come out. Those do come out, and Alex, they do come out a little bit on the STAR test. Benchmarks for sure. I don't know what to tell you. Okay, so let me erase all this stuff. Okay, let's look at this real quick. So again, let me go ahead and draw the parent function. Ooh, guys, we didn't even write the words. So let's see the words that they wrote over here. Compressed vertically. You got it? They squashed it, went wider here. This one over here, I forgot to show the words on this one. Jeez. The dilation, okay, so they went ahead and did what? Translated 2 units up and stretched vertically. Okay, so there's a lot of keywords that we need to work with here. I forgot to mention this part over here about when compressed, these right here. So let's go to today, or the one that we're working on right now. Okay, so let's look at this that we're working on right here. The parent function is going to be from here, going like this. That's the parent function. That's x squared, okay? This one now, what's going on with this one here? Can anybody tell me what goes on with this one? Give me something, guys. Something. Anybody know anything about this one? And I'll do it in green too. How about this? Does anybody know what this one does over here? What this -2? Let's start off real simple. What does that -2 do? It goes down 2. So my vertex goes down 1, 2. I'm not lying to you? Yes. Now, is there any right or left? Any right or left? I'm going to say no because you don't see it like this. You don't see it like that, right? Sorry about that. So yes, that one goes down 2. My vertex goes from there to there. Now, what does this 5 do? You've got to help me out. Look at this 2. Look at this 5. This 2 made it like this. What does this 5 do? Tristan makes it way more narrow. More narrow than this one. So if I'm saying that one's 2, then this one's 5, which is, whoa, like more than twice of that one. It makes it, because you think about this, Tristan, you put the x values in here, x to be 1, it becomes, for the parent function, it becomes x squared becomes 1. But for this one, you put x squared here, it becomes x squared, and then times 5. It's way up here, 5 times higher already. These make it grow fast, make it be narrow. This one here, on the other hand, makes it wider. Okay? Let's try the, what does this one do now? Talk to me what this one does. Okay? Yeah, it just takes practice. Don't worry, it's barely learning how to do this real quick. So for this one right here, it's translated 2 units down. And how do y'all want to say it? Do you want to say stretch vertically, compressed horizontally, narrower? What is it y'all want to put? A, B, or C, other? A, okay, we're going to go and say stretched vertically. There it is. Let's try 4C now, ready? Jennifer, try 4C real quick on your own. I'll do the parent function. Please make sure you know the parent function goes through 1, 1 and -1, 1. Okay, those help me out a lot. This one here in green. Okay, you should be doing this one on your own. I'm just going to give you the answer. That one's I do. I did the I do's with the book. We did these past ones. Oh! Here it goes. Ready? For this one here, we're going to go ahead and say for this one here, we're going to go ahead and say, ready? This one goes up 2 units and wider. So I would go 1, 1, right? I'm going to go wider than that. And this is g of x. What it did, okay, it translated 2 units up, and we'll go ahead and say compressed vertically. Okay, you do have an assignment on this one, guys? I did tell you I was going to make another, I guess, a Google Classroom for you all. Here it is. Don't forget, it's there just in case. There's the Google Classroom, so you can go ahead and join. I'll post it one more time. Boom, brothers. Open house is from 4:30 to 6:30. I'll leave it there open so your parents can go ahead and see it, and then you can go ahead and contact me, guys, or your parents can contact me afterwards in case you need help. Okay, guys, y'all have a good lunch. I barely saw it's 11:47. Wow, lunchtime. Thank you all for staying. Be safe. Have a good lunch. Bye, Tristan. We'll see you, brother.